Assalamu alaikum everyone. I hope everyone is well. So in this video I'm going to focus on the mathematical concept of surds. I'll briefly explain the concept of surd and then go through some problems regarding this concept. So let's jump straight into the video. Before going into the mathematical problems related to this concept, which is surds, we first need to understand what actually surds mean. So if I go to Google and type what are surds in mathematics, I go to the people also ask session and look at the first example. So people frequently ask this question, what is surd with example? So surds are square roots of numbers that cannot be simplified into a whole or a rational number. So it cannot be accurately represented in a fraction. It cannot be accurately represented in a fraction. In other words, a surd is a root of the whole number that has an irrational value. So consider an example. Root 2 is very close to 1.414, but it's not actually the exact the exact fraction cannot be represented. That's why it shows approximate. So if I go to the cider, this is a tool that I used. So the answer you can get here is also similar. Surds in mathematics are square roots of numbers that cannot be simplified into a whole or rational number. So they are represented in the form of roots. So the numbers, these numbers, surd numbers, are represented in the form of roots and considered irrational numbers. So example of surds includes root 5, root 7, root 15 by 7, etc. So for example, this number, let's say if I use my pen tool, notepad and pen tool. So this number, root 2, this is approximately 1.4, but the exact fraction, we don't know the exact fraction. So that's why this is a surd. Let's represent surd with S. So this is a surd. Similarly, root 5, this is approximately something like 2 point something like 1, or but the exact approximation cannot be done. That's why this is also a surd number. Surd numbers are the primary identifier is the surd numbers are represented in roots or cube roots, in square roots, square root and root are same, or in cube roots, etc. So they are represented in these forms, surd numbers. So this is the basic idea of surds. So if I look at the first problem of these exercises, which has 3 categories, medium, hard and very hard. I'll focus on the hard part because there's only 3 part and I chose the middle one. So let's focus on problem 1, which has 2 parts, 1a and 1b. So what does it say? So 1a says show that 5 by root 2 can be written as 5 root 2 by 2. So you have to show that this expression can be written as this expression. So if I use my notepad, so 5 by root 2 by root 2, this can be written as what? 5 root 2 by 2. So how can you represent 5 by root 2 as 5 root 2 by 2? So if you actually look at this structure, it is what? 5 multiplied by root 2 divided by 2 can be represented as root 2 multiplied by root 2, because the multiplication of root 2 and root 2 is what? 2, right? So as you can see, the root 2 is above and below, like in the denominator and the numerator is there, so we can cut off. So as you can see, this is 5 by root 2. So we can multiply both sides with root 2. So we can multiply with 5 multiplied by root 2 and root 2 multiplied by root 2. So we can now denote it as 5 root 2 by 2. So this is how you can express 5 by root 2 as 5 root 2 by 2. Notice we didn't do any fraction here, because fractions won't give you the exact number, it will give you an approximate. That's why you have to express this as a surd number, which includes this root part. Any number that includes root or cube root is a surd number. So if I go to the problem 1b, it says show that 2 plus root 3 whole square minus 2 minus root 3 whole square is 8 root 3. So as you can see, if I write 2 plus root 3 whole square, so 2 plus root 3 whole square minus 2 minus 2 minus root 3 whole square minus 2 minus root 3 whole square, this is represented as what? You have to prove that this is 8 root 3. So as you can see, this can be written as the formula of what? A plus B whole square minus A minus B whole square. So you just have to use the formula, which is A plus B whole square. What is the formula of A plus B whole square minus A minus B whole square? This is A square plus twice AB plus B square, and this is A square minus twice AB plus B square, and there is minus. So this is what? 4AB, right? So this would be what? 4 multiplied by, we use A as 2, right? So multiplied by 2 multiplied by B was what? Root 3. So this is root 3. So this is what? 4 multiplied by 2 is 8. 8 multiplied by root over 3. This is a surd number, and this is what was required here to prove. Now let's focus on problem number 3a. Let's read this. So Martin did this question. So the question says you have to rationalize the denominator of 14 by 2 plus root 3. So you have to remove the denominator and express this as a purely numerator based number. Okay. So you have to remove this part, which is the denominator. So let's see how he answered this. This is how he answered this, and this is the answer that he got, but the answer is wrong. So you have to find the mistake that Martin made. So let's now focus on this part. Let's first try to solve this ourselves and match it with where Martin got wrong. Okay, so let's focus on this 14 by 2 plus root 3. So if I use my pen tool, 14 by 2 plus root 3, right? So you have to remove this part, which is the denominator part. This is the denominator, right? This is the denominator part. So you have to remove that. So how can you remove that? So as you can see, this is like this can be expressed as A plus B. So we can use something in the numerator which is something similar to A minus B. We can multiply something like A minus B in both numerator and denominator to put it into a formula like A plus B into A minus B. So we can write something like 14 by into 2 minus root 3 divided by 2 plus root 3 multiplied by 2 minus root 3. Okay, so as you can see, we can put it in a formula like A square minus B square, right? So we can put this in this whole number in a formula like this. The numerator part is there, which is 14 into 2 multiplied by 14 into root 3. So which is 28 minus 14 into root 3, which is 14 root 3. Okay, and the denominator part is what? 2 square minus root 3 square, which is A square minus B square. Okay, so this can be expressed as what? 2 square minus 3 square is what? 4 minus root 3 square is what? 3. So this is 1. So this can be expressed as the denominator part is 1, which is basically the denominator part is no longer needed. So we can write directly, which is the answer is 28 minus 14 root 3. So this is the answer to the question. So Martin got it 4 minus 2 root 3. So where did he got it wrong? So as you can see, this is how he tried to answer the question. So he took both 2 minus root 3 he multiplied 2 minus root 3 with both the denominator part and the numerator part. So the numerator part is okay, which is 28 minus 14 root 3, but the denominator part is what? He tried to multiply it like simply, so basically 2 multiplied by 2 plus root 3, which is 4 plus 2 root 3, minus root 3 multiplied by 2 plus root 3, which is root 3 multiplied by 2 is 2 root 3, so minus 2 root 3. But when you give minus, this would be minus. So basically he made a mistake here, which was this would be a minus. So 4 minus 3 would be 1. Instead he got 4 plus 3, which is 7. So this is what he got it wrong in this part. I'll now focus on problem number 5. What does problem number 5 says? It says that you have to show that this expression root 5 multiplied by root 8 plus root 18 can be written in the form a root 10 and state the value of a. You must show your full working. So if I use my pen tool, it says what? The expression root 5 multiplied by root 8 plus root 18. Root 5 multiplied by root 8 plus root 18. This expression you have to translate this into something like a multiplied by root 10. Okay, you have to express it as a root 10. So let's see what we can do with this. So as you can see, this term root 8 can be expressed as what? Root 8 is what? Root 4 multiplied by 2. So this is what? Root 4 is 2 and root 2 is multiplied by root 2. So root 8 can be expressed as what? 2 root 2. And what can root 18 be expressed as? Root 18 is what? Root 18 is what? Root 9 multiplied by 2. This is what? Root 9 is 3 and root 2 is root 2. So this is 3 root 2. So root 8 plus root 18 is what? 2 root 2 plus 3 root 2. So what can we express this? Root 5 multiplied by 2 root 2 plus 3 root 2 is what? 5 root 2. Okay. So this is root 5 and this is root 2. So we know that root a multiplied by root b, this can be expressed as root a multiplied by b. So root 5 multiplied by root 2 can be expressed as root 5 multiplied by 2, which is root 10. So this can be expressed, this expression can be expressed as what? Can be simplified as 5 multiplied by root 5 multiplied by root 2 is what? Root 10. So this is root 10. So if we match a root 10 with the expression a root 10, what is the value of a? The value of a is 5. So a is equal to 5. So this is the value that we want to derive. So you have to state the value of a, which is 5. So you must show your full working. This is the full working of this problem. I hope you get some idea about what surd is and how we can solve problems regarding this concept of surds. In the next video, I'll focus on some more problems, some different types of problems regarding this concept. So stay tuned for that.